Hello everyone, Milt Olson here with Maintenance Technology Systems. Got our MTS Explorer software open to the spectrum plotter, the FFT plot. And we're going to go through some of the ins and outs of the FFT plot to give you an understanding of how it works, what's there, and so forth. So we've got a data set here from January 6th of this year. Note that it is over here on the right hand side, it's got our date and time stamp, our cursor value, our overall value. Note that the frequency range is 4200 hertz. I can change that. Let's say I wanted to look at 2000 hertz. I can simply click on 2000, or I can double click here and type in 2000. And that will is how I change that. If I wanted to change the amplitude, I simply roll the mouse wheel, roll it back, and you can certainly see that. I can click and the mouse will come to my location. Use the left and right arrow keys to kind of hit on the exactly on the peak. While we're on that, if I click over here in this right hand bar, just a left click, it gives me the 10 peak list. Note that we've got 114 hertz, 0.040, so it pulls out the exact value of each of those peaks. And that will just go along for the ride unless I close it, and then it'll go away. Show you a couple other items on that. Let's let's just do 4. And sometimes I have to hit the previous next to get it to display that. Once again, my mouse wheel still works. This is plot 1. I can get by clicking in the plot 2 area, I can get the plot 2 peaks. Notice the one here at 400 hertz or so, it's 0.026. That looks like it's the right one. Plot 3, plot 4, plot 1, and that's how that one works. I can look at it in any of the vibration units. I can look at the acceleration spectrum. Notice that it updates with the acceleration values. We got about 0.14137 at 465. That guy there shows up nicely. Should have one out here, 1100 or so. 1169 is 0.123. Yep. So it kind of follows where you click, which is kind of a nice thing, just as a quick way to look at those data points. We can also look at displacement spectrum. We might want to bump that out to 500 hertz, roll it up, take a look what's there, or those peak numbers. Okay, so I'm going to drop it back to velocity here. I can look at it with a single cursor. A harmonic cursor, note that it just kind of moves around and keeps track of stuff based on the original cursor's position. Or I can do a sideband cursor. So I can drag the middle one wherever I want. The one just to the right, I can pull down and get that to be that distance. Then I can move the whole family just by clicking and dragging, or just a click and it'll jump to where I'm at. So there's how we move the cursors around. I'll put this back to harmonic. We've got a triaxial sensor, so we can look at a horizontal, vertical, or axial. And we just click through those. Or we can look at one that includes all 3. And that'll just put us onto a single plot. And I'll show that here. So I'll pull up a single plot. And that's the peak hold. Axial's 0.14. Vertical's smaller. Horizontal's 0.048. So if I do a peak hold, then my maximum value should be that 0.14 from there. It does a peak hold at every spectrum. So I'm going to put that back out at 2000 hertz. Going to click on this guy and note that it shows that way. That's the peak hold spectrum. Of course, we have hertz, RPM units, or orders. Right now we have a high resolution spectrum showing. The default is a single spectrum of the entire waveform. We've got a 5-second waveform on this particular data plot, and so the total number of samples are around 50,000 samples, or 50,000 lines of resolution, which seems really high compared to how people typically look at things. So we can say, let's say I just wanted to show 4 averages. The resolution goes down, but now I have a 4 average spectrum. I can do a 24 average spectrum. Resolution goes down a little bit more. But what happens is we do, to get to 24 averages, we do spectral or overlap processing. Overlap processing allows us to get us, up to 24 averages out of the single data set in the post-process sense. So that's how that one works. Going through the rest of these, we've got a status bar here. It tells us the description of the machine, its ID, its machine description, and the measurement location description. If I wanted to change this RPM, let's get a cursor right here on this peak here. I believe that's going to be our primary peak, our shaft speed peak right there at 17 hertz. And if I hover over this, says type in the shaft RPM, hold the shift key to use the current cursor position, hold the control key to calculate current cursor position. So I'm going to hold the shift key when I click on this, and it puts in that RPM. And now as I do that, it will actually store that for future analysis on this machine. And so that's how I can set the RPM. Oh, if I'm going to add a report on this machine, I simply click on the clipboard, pops this guy up. I can do that, and we'll cover this in more detail on the reporting. Saves the current picture of the machine to include in that. I'm just going to cancel out of this so I don't create a new thing in my database. Anyways, that concludes this video. Hope it's been beneficial for you.